we have understood is that object distance is equal to image distance for a plane mirror, and image formation is of virtual nature. So the light rays are not actually meeting. We are deliberately doing some geometrical construction for achieving that purpose. Now, let's say you have a situation in which this is your plane mirror. And the object is lying over here, separated by 100 meters from the mirror. Where would the image be formed at? It makes no intellect to just say that it would be 100 meter behind. This is very easy. Now let's say I move this object by 4 meters. What will happen to the image? If I move the object by 4 meters, now my object separation becomes 100 minus 4, 96 meters. So even the image separation would change by that amount. So that would give you the new image formation, 96 meters behind. This is your I dash and this was your O dash or O prime or I prime, whatever you prefer. So even this has moved by 4 meters towards this side. So if the object moves towards the mirror, the image also moves towards the mirror, right? Now this goes on to something more about object image for a plane mirror. Object speed would be equal to image speed if the mirror is at rest. Let's try to understand that with a numerical. Let's say you have again a plane mirror. It's at rest. The separation is of 20 centimeters. This is my object over here. So naturally the image would be somewhere behind, 20 centimeters behind. What you need to find out is if the object is moving with 3 meters per second, what would be the separation between object and image after 5 seconds? I'll write the question for you. Separation between object and image after 5 seconds. How do you find that? How? I know that after 5 seconds, this would move towards the mirror by 15 meters per second, or rather 15 meters. Sorry about that. So after 5 seconds, it would move towards the mirror by 5 into 3, 15 meters, which means now my object is 5 meters away from the mirror, which means the image would also be 5 meters away from the mirror. So this is my separation, 10 meters, and this is your answer. This is equal to 10 meters. There's one more method of doing this question. I know that image speed and object speed would be constant based on this analysis or this discussion. So if image speed and object speed are equal and constant because my plane mirror is at rest, this 3 meter per second is also the speed of the image, and by that amount image is coming closer to the mirror. So object is coming closer to the mirror by 3 meter per second and image by 3 meter per second. So net I have a 6 meter per second of a reduction in the separation between object and image. I have just used a simple analogy of relative motion. If two guys are coming close to each other with some V1 and V2 and D is the initial separation, so D upon V1 plus V2 would be the time it would take to collide, and rather what's happening is V1 plus V2 is the time of V1 plus V2 is the rate at which the distance is decreasing, and time, if given as T, V1 plus V2 into T would be the amount of change in separation. So over here 3 plus 3, 6, 6 into 5, 30. So 30 is the change in my separation. My initial separation was how much? 40. So 40 minus 30 gives you 10, which is the answer. So you can do by either method and you'll arrive at the same answer. Now let's try to put a bit of complications here. The mirror now is not at rest. Let's look at that situation. So you have a mirror which is not at rest. This is moving towards the right with 4 meter per second. Just put a dashed thing to denote that this is a plane mirror. Now the object is here, some 10 meters away from the plane mirror, and it's not at rest. Even this object is moving. This is moving towards the mirror with 1 meter per second. So you have an object moving towards the mirror with 1 meter per second and the mirror moving away from the object with 4 meter per second. What you need to find out is the separation between the object and image after 3 seconds. So the question remains the same. Separation between object and image after, in place of 5, 3 seconds. So I'll just write SEP for separation. Understand its separation between the object and image after 3 seconds. How to find this out? In here, it's slightly complicated, but even then you can do it very comfortably. After 1 second, what will happen is this guy would move by 4 meters and this object would move by 1 meter. So net increase is of 3 meters, which goes to say that this minus this is the rate at which the object distance is increasing, which makes perfect sense, because if both were moving with the same speed in the same direction, the rate of separation change would be 0, or the separation would remain the same. But here this is higher, this is lower, so there would be an increase in separation of the object from the mirror, and that rate is 4 meter per second minus 1 meter per second, which is very easily 3 meter per second. So this is the rate at which the object is getting separated away from the mirror. If object is getting separated away from the mirror, even the image would be separated away from the mirror with the same rate, and separation means speed in the opposite direction, in the opposite sense. So what will happen is, I'll make a simplified diagram. Object would seem to move away from the mirror with 3 meter per second, and the image over here would also move, or rather seem to move, with 3 meter per second. Initial separation between them was 10 is the object distance, so 10 would be the image distance, so 10 plus 10 is 20. So the initial thing was 20 meters. So after 3 seconds, this 3 and this 3, if you add them up, they're increasing separation, they're making separation higher value. 6 times 3, 18. So new separation would be simply 20 meters plus 6 times 3, which is 18 meters, equals to 38 meter. And over here, I could have made this question of a different way if this 1 meter per second is not in this direction but in this direction, right? But it doesn't matter. No matter in which direction the object is moving and the mirror is moving, I can always apply the same logic. Object distance is equal to image distance, or rather object separation from the mirror is equal to image separation from the mirror, and rest all is very same. Simple kinematics, relative motion. Now, there are two things about plane mirror which you need to know apart from image formation. It's, let's say, this is a plane mirror over here, rather here. This is a normal. If this is your incident ray, this is my reflected ray. If there was no mirror, I would have followed this path. But I'm following this path, which means this is my deviation. Deviation produced by plane mirror. And what would be the value of deviation? If this angle is your I, even this would be I, R is equal to I. So this, by the logic of linear pair, it would be simply pi minus 2I. So the deviation produced by a plane mirror is known as, or rather the value is equal to deviation by a plane mirror of a ray of a light, of an incident ray of light, is equal to pi minus 2I. If the measurement of angle is in terms of radian, or you can also say 180 degrees minus 2I if the measurement is in terms of degrees. Now this was deviation by a plane mirror. Now I can also change the orientation of this mirror and then effectively change the reflected ray. My reflected ray could change its path. How? Let's understand that. This is my mirror over here. Incident ray, normal, reflected ray. If you tilt this mirror by some amount, let's say that tilt is by delta. This is my new orientation or new position of the mirror, and this angle over here is your delta. This was initially I, even this was R equal to I. I'll simply write I, that would suffice my case. If I have moved the mirror by delta, this is the same mirror, see, don't get confused with the length of the mirrors. This is just a freehand diagram, so you could have a small difference over here. But this is the same mirror which has been tilted by delta, which means my normal would also be tilted by delta, which is like, I'll tell you one example over here, how to find out the angle between two things. If this is your joint, or rather your welded two pieces of rod, if you tilt this rod by delta, even this rod would be tilted by delta from the horizontal, which means my new normal would be this and tilted by delta from the horizontal. So if this is your new normal, which means my new angle of incidence is this one, which is equal to whole was I, this angle was I, but delta has gone. So this is your I minus delta. Now my reflected ray would also make a smaller angle. This is my incident ray, which cannot change because I'm not changing my incident ray. My reflected ray would change. If I minus delta is my new incident angle or angle of incidence, even my angle of reflection would be I minus delta, which means that the angle which I will make with the new normal, this is my original or rather the old reflected ray, and this is my new reflected ray. New so this angle over here would also be I minus delta. This is also I minus delta. But I know the total angle over here was 2I. 2I. But I have only taken this I minus delta plus I minus delta, which means this is my deflection or deviation produced by tilting of the mirror. That would be 2I minus this angle, 2I minus twice of I minus delta, and this would give you, if you open up the bracket, 2I goes away, you have minus minus plus 2 delta, which means this is your deviation or deflection produced by tilting the mirror by delta. So if tilt of mirror is of delta, deviation or deflection would be of twice that amount.